Christine up.
Christine, I'll put the cam on. There's me. So thank you very much for the opportunity. If my slides come up, I can start. I'm talking on behalf of the forestry industry. With the forestry growers, commercial companies, and R&D, our R&D centre, which is the Forest Wood Products Australia, have been investing in remote sensing for over 10 years now, and many commercial companies management systems, and unlike a lot of farming enterprises, private growers have much larger estates to manage, which are fairly fragmented, and of course there's the native forest, which is of hundreds of millions of hectares. And because of this hierarchy, the area that's covered by forests, we need to take on a hierarchical sampling. Spatial temporal sampling program is normally accepted, which includes a multi-phase sampling strategy. Next slide, please. Next slide. Can I get the next slide? Yeah, thank you. Starting off with the Landsat, not Landsat, the satellite type of imagery that we can utilise. This is for the case of native forests. Something that's now been progressed quite significantly is time series analysis, where we're using multi-temporal images, principally from Landsat, but we are moving to Sentinel, where we can actually monitor and map and monitor spatially where and over time where disturbances have occurred. You may recall that this last summer we had the terrible fires, and in New South Wales over 5 million hectares of native forests were burnt. And this approach will allow us to look where the disturbances are occurring, drought, pests and diseases, fire, etc., and map that over very large areas. Next slide, please. On a higher resolution, spatial resolution, looking at plantations now, we have adopted UAV platforms in particular, but we also, the industry uses airborne camera imagery, and this is a 3-band camera digital imagery of a plantation which has disease impacted on the foliage. In particular, it's a fungal pathogen. And using photogrammetry, we're able to actually map the extent, the location, and the severity of this particular disease, which causes necrotic foliage at the individual tree level. The other example is from airborne imagery, and there we're looking in a pine plantation, automatically counting the number of tree crowns, but also classifying those tree crowns into either green or dead, being killed by Syrinx wood wasp. Next slide, please. Next slide, please. Now moving on to LiDAR, and the reason the industry, no, too far, gone too far. Reason we're invested in LiDAR is because forestry is a 3-dimensional structure where you have both spatially and vertically a lot of heterogeneity, especially in the native forests. But LiDAR, with its active pulses per square metre, is able to provide us with data that gives metrics related to cover, vertical profiles which relate to height and gives us an estimate of understory and overstory, the actual variability or how rough that surface is, and the also the profiles that will give us information of how that changes over time with respect to harvesting events, etc. Next slide, please. One thing that the industry and as well as native forests we've moved into is acquiring the active point clouds from LiDAR, but at very, very high resolutions. The technology is improving significantly. Here's an example of a helicopter that has a Regal VUX1 LiDAR sensor on it that enables us to the helicopter moves from plot to plot and is able to hover over that plot and capture hundreds of pulses per square metre, and that gives us an impression of a 3D image in the point cloud, 3D point cloud. Next slide, please. Here's an example of a very dense LiDAR 3D point cloud, which was acquired not from an airborne system, such as the helicopter, but from a mobile laser system, which is similar to a terrestrial laser system, but it's actually held in the hand or put on a backpack. And in this case, this is data acquired by an instrument, a sensor called a HoverMap, which was acquired very recently by Hancock's Queensland Plantations and a forest service provider called Interpine in New Zealand. And what they're doing is capturing, they don't have to, traditionally, there's been a need to measure these trees manually, walk in, measure the diameters manually, measure the heights and other characteristics of individual tree stems. That requires a lot of time and effort, and there are also safety issues associated with walking into these plantations. It's hoped that we'll be able to do these remotely, but at this stage, it's still significantly improvement in that someone can now walk in, walk around in a spiral, collect the data. That data is extremely high density point data, is then brought in and segmented with automated segmentation algorithms so that you get the individual stems created. This enables algorithms such as taper and other stem attributes to be provided. These segmented stems are then brought into a virtual reality platform, and that's the final slide showing you it in the virtual reality, where it can be done, the same tree measurements can be done in the office as now done manually in the field. Thanks.
That's fantastic, Christine. Much appreciated. And apologies for the